Good evening. Welcome to another video of Vedantu Karnataka. Today we are going to look at very important fixed questions for your exam too. So quickly, can you all let me know in the chat if I'm audible, visible? Yes. So I got some requests on to do the class at 5. That's why I'm doing the class at 5. So you can all after the class go and study whatever is done today. Okay? Are you all scared? Are you all excited? Can you let me know? Good evening, good evening. Students, since there is a small time change, can you all quickly send this link in your groups and tell everybody that the class has been moved to 5, it's not at 7. So can you ask all your friends to quickly join? Can you do that? Yes, quickly. Yes, hi, good morning, good evening everybody. Yes. So we'll start fast. So today we will be doing the most requested thing, which is numericals. First, okay, we'll be doing important questions, but first we will look at numericals, both 3 markers and 5 markers. Okay, so first we will look at 3 marker numericals and then we'll look at 5 marker numericals. Then we will look at 5 marker main questions, most repeated usual questions. Is that fine? Are you all ready? Are you all ready? Yes, can I have some fire in the chat if you're all ready for this class? Quickly, can I have some fire? Hello, Rachit. Yes. Are you all ready for today's class? So students, we right now have 27.9k subscribers. And we've been working a lot for all of you. Can you all please subscribe the channel? So let's make it 30k subscribers after this class. Okay? Quickly, let's make it 30k subscribers. Okay, so let's start today's class. We will be starting with numericals as I promised. So many people have been asking me, ma'am, numericals. So today we are going to start with numericals. The first set of numericals that we are going to do are 3 markers. Okay? Are you all ready? Ma'am, last time full wave they asked. So this time half wave. Yes, RCB won yesterday's match. Very well done. So I want all of you to win tomorrow's physics exam. Okay, so let's start. First question. All of you get your pen, paper. First question. 2 capacitors. Once again, yeah. 2 capacitors of capacitances 2 picofarad, 3 picofarad and 4 picofarad are connected in parallel. What is the total capacitance of the combination? Determine the charge on each capacitor if the combination is connected to a 100 volt supply. Okay, quickly I want the answers. Yes. So you have 3 capacitors in parallel. So what is the formula for capacitors in parallel? Total capacitance is C1 plus C2 plus C3. So that is what is done here. Right? Can you see because of my head? Okay. So the 3 capacitors have a total capacitance of 2 plus 3 plus 4, which is 9 picofarad. Now this is done. Now determine the charge on each of the capacitor. What is the formula for charge? The charge is Q is equal to CV. Now in the question it is given that we are connecting it to a 100 volt supply. Now we know the capacitance, we know it's 100 volts. So what we will do, we will find it for each. So the charge on 2 picofarad capacitor will be 200, charge on 3 picofarad it will be 300 and charge on 4 would be 400. Okay? So we have to find out the charge on each capacitor. That's why we found out each one. Simple question. This is a 3 marker. Okay? This is a 3 mark question for your second exam. Is this clear to all of you? Direct question? Yes? Good evening, Asha. Okay? Let's move on to the next question. Next question. What is the question? 2 positive charges. Okay? 2 positive charges. 12 microcoulomb and 8. So 2 positive charges. 12 microcoulomb and 8 microcoulomb are placed at a distance 10 centimeter apart. Okay? The work done in bringing them 4 centimeter closer. So right now the distance between them is 10 centimeter. You have to bring them 4 centimeter. So this has to be made into 4 centimeter distance. So how much work you have to do to bring these charges together is the question. Is the question clear to everybody? So let's quickly solve the question. Okay, first one. Q1 is how much? 12 microcoulomb. Yeah. Q2 is 8 microcoulomb. The initial distance is 10 centimeters. Final distance is 4 centimeter. All that I've already written. I've typed all the solutions so that we don't waste a lot of time. Okay, and quickly we finish the class so you can go study. Alright. The permittivity of free space, epsilon naught is 8.85 into 10 raised to minus 12. You all know that. So first, let us find out the potential energy between the charges in case A. And then we will find out the potential energy for case B. Okay. So for case A, what is the formula for potential energy? 1 by 4 pi epsilon naught Q1 Q2 by D. So let's substitute. 1 by 4 pi epsilon naught is 9 into 10 raised to 9. 1 by 4 pi epsilon naught is 9 into 10 raised to 9 into what is the first charge? 12 microcoulomb. 12 into 10 raised to minus 6 into second charge is 8 microcoulomb. 8 into 10 raised to minus 6 divided by what is the distance? Initially the distance is 10 centimeters. So 10 centimeters is how many meters? 10 by 1000, 0.1 meters. Is this clear? Now if you do the math, you will get 8.64 joules. I want you to quickly do the math. So I have already taught you how to do this. You have to do the numbers first and then the powers separately. Now, what I'm going to do is I'm going to find out the potential energy at the new distance. So same formula, but instead of this D, I will take 4 now. Okay, which is case B. Now, calculating potential energy U2 at distance D2. So what will it be? 1 by 4 pi epsilon 0 is going to be 9 into 10 raised to 9. Q1 is again 12 into 10 raised to minus 6. Q2 is again 8 into 10 raised to minus 6. But D2 is going to be 4 centimeters, which is 0.04. Okay, same formula 2 times. First the distance is 10 centimeters, second the distance is 4 centimeters, that's all. Now I have the potential energy initially, potential energy after some time. Okay, I have the potential energy when the charges are 10 centimeters apart, potential energy when the charges are 4 centimeters apart. Now what is work done? Work done is the change in potential energy. So work done is U2 minus U1. The change in potential energy when it was 10, when it was 4. So you will get 12.96. This is also a simple question if you understand. Okay. Is this fine? Is this fine? Yes? Can you all let me know in the chat? Put some fire in the chat if this much is clear to you. 2 questions done. Less than 10 minutes. We'll finish off quickly today. Okay, I'm not going to take a lot of your time. In less than 2 hours, we will do everything important. Okay? Yes. Quickly, students, can you let me know in the chat if this is clear? Clear? Okay. Let's move on to the next question. These are all 3 markers and they're not that difficult. So I don't want you to lose marks for 3 marks. Okay? Okay? Sabash? Yes. Very good. Next question. Charge through a cross section of a conductor is given by Q is equal to 5t square minus 2t. Okay? The charge Q is what? 5t square minus 2t. Super. Find the average current through the conductor in the interval t1 is 3 seconds to t2 is 6 seconds. So I have to find out the current and the time is between 3 seconds to 2 seconds. Okay? Alright? Yeah, 5 mark numericals I will do. Okay? Can you wait patiently for like 5 to 10 minutes and then we'll do 5 mark numericals. Don't worry. Okay? Yes. It will be less than 2 hours, students. Quickly we'll finish off. Okay? So 5t square minus 2t, you have to find out current and the time is between 3 to 6 seconds. Now what is the formula? All of us know current is what? Charge by time. Yeah? That is the formula. Current is Q by T. Yeah? Q is equal to IT. So I is equal to Q by T. Now what will average current be? Average current will be the difference in Q divided by the difference in time. Q1 minus Q2 divided by T1 minus T2. So what will we do? We'll do some substitution. Now we know that charge in general is what? 5t square minus 2t. Okay. Now what we will do? We will take 2 cases. First when t is 3, then when t is 6. Why? Because it's given in the question. In the question it says qt is equal to 5t square minus 2 at t is equal to 3 to t is equal to 6. So now first what I will do, I will substitute 6. So what will it become? 5 into 6 square minus 2 into 6. 5 into t square minus 2t. So 5 into 6 square minus 2 into 6, which is 180 minus 12, 168. Now what I'll substitute? Here I'll substitute 3. So it will be 5 into 3 square minus 2 into 3, which is 45 minus 6, 39 coulombs. Alright? Alright? Yeah? Okay? So now what will it be? You have the charge. Now you just find out the I average. I average is what? Q by T, and you will get the answer. Very easy. Okay, quickly, next question. Yes. Yes. Quickly, students, let's move on. Look at the next question. Estimate the average drift speed of conduction electrons in a copper wire of cross-sectional area 1 into 10 raised to minus 7 meters square, carrying a current of 1.5 amps. Assume the density of conduction electrons to be 9 into 10 raised to 28 meters square. Okay? Hello, Kings BGM. Okay? How will we do that? I is equal to NEA VD is I by NEA. Okay? So, direct substitution. What is current? Current is given as 1.5 divided by N is number of charges, 9 into 10 raised to 28. E is 1.6 into 10 raised to minus 19. Area is 1 into 10 raised to minus 7. You do the substitution, you will get 1 into 10 raised to minus 3 meters, which is approximately 1 millimeter. Simple question, no? Direct substitution. Right? These are all for 3 marks. Okay? I'm already doing it very fast. I can't go faster than this. I can't speak faster than this. Some of them are asking me to do it in 2x speed. Yes, you will definitely pass if you study this. There's also a pass package that I've uploaded. Those who want to only pass, you can study that as well. Okay? Are you all with me? Yes? No? Yes? 5 marks I will do. Okay? Okay. In a circuit, a 5 amp current flows for 6 seconds. Okay? So 5 amp flows for 6 seconds. If the resistance of the circuit is 8 ohm, calculate the number of electrons flowing, the amount of heat produced. Okay? Yes? 5 amp current is flowing for 6 seconds. Resistance is 8 ohm. We have to find out the number of electrons. So what is the first thing we will do? We'll find out what is the charge. What is charge? Q is equal to IT, which is 5 into 6, which is 30 coulombs. Okay? And then that is giving you the number of electrons. So there are 30 coulombs of charge. So how many will be there? N would be what? N would be 30 divided by the charge of 1 electron. Okay? Which is 1.875 into 10 raised to 20 electrons. Alright? Now, next one. You have to find out the heat produced. What is the formula for heat produced? H is equal to I square RT. And how much would that be? 5 square into 8 into 6, which is 1200 joules. Okay? Alright, next chapter. Is this fine? Students, let's not spam the chat today because there are students asking doubts. I missed those doubts if there are. Okay, fine. Yeah, you can use this for 5 marks as well if they're not going to be there for 3 marks. Okay, next question. A straight wire of mass 200 grams and length 1.5 meter carries a current of 2 amps. Okay? It is suspended in mid-air by a uniform horizontal magnetic field. The magnitude of B in Tesla is, assume G is equal to 9.8 meters per second square. Okay, so what I'm going to do, I'm going to find out the magnitude of magnetic field B. So one formula I know for B is F is equal to ILB. But in the question, force is not given to me. So what will I do? I'll find out force by finding out weight. See, from Newton's second law, you know F is equal to MA, which is equal to mg. Weight is also mg. So force and weight are similar. So can't I just find out force if I find out weight? So weight is mass into gravity, which is 0.2 into 9.8, which is 1.96. Alright. Now weight is going to be equal to force. Now I will rearrange this formula. ILB is going to be equal to W. Right? ILB is F, can be written as ILB is going to be W. So what is current? Look at the question. 2 amps. So current is 2. Length is 1.5. B I don't know. I have to find out. W is how much? The weight. Mass into gravity. 1.96. Now rearranging this, what is B? 1.96 by 2 into 1.5. So it's going to be 0.653. This is going to be the magnetic field. So in this question, the only tricky part is you need to know that weight and force are the same. And then you need to know the formula F is equal to ILB. Is that much clear? Yes? No? Yes? Can I have some response from you? Is this much clear? Can I know in the chat? Yes, you can use B is equal to mg by IL as well. No problem. Okay? Yes. Next question. Okay? Yeah. An object is placed at a distance of 40 centimeters. An object is placed at a distance of 40 centimeters from a concave mirror. Okay? So let's say there's a concave mirror. Let me draw a concave mirror. Okay? Are you all there in the class? Let me draw a concave mirror. So an object is placed at a distance of 40 centimeter from a concave mirror. Okay? The focal length, this much, is 15. Focal length is 15 centimeter. If the object is displaced through a distance of 20 centimeter towards the mirror, what will be the distance of the image? So what happens? This object is now at 20 centimeters. F is still 15. So initially the object was 40. Then the object moved to 20. So how much the image will shift? In both the cases, you have image formed, right? So the question is, by how much the image will shift? Okay, so let's look at the parameters. For the first one, obviously U is on the left side of the mirror, so it's going to be minus 40. For the second one, U2 is minus 20. Focal length in both cases is minus 50. Okay, question is clear? Let's quickly solve it. What is the mirror formula? 1 by V is equal. 1 by V plus 1 by U is equal to 1 by F. Isn't it? That is the mirror formula. 1 by V plus 1 by U is equal to 1 by F. So substitute. Let's do it for the first case. Let's do it for this one. So for A, what all we have? We have V1, U1 and F. So what is my 1 by V1 is what I have to find out. So 1 by V1 will be 1 by F minus 1 by U1. How much is it going to be? Focal length is 15 and the object distance is 40. Minus minus, it will become plus. So you will get minus 1 by 15 plus 1 by 40. If you do the math, you will get minus 24 centimeter. Simple cross multiplication. Okay. Now what I will do, I have the object here. I think I can do a better job. Let me just draw it once again, students. Just a second. I'll reduce the thickness. Yeah. This is a mirror. this is 40, this is 15. So this is my U, this is my F. Now I got that V is at 24. So V is 24. I found this. Now I'll do the same thing for the second case. But here I will take 20 centimeter as my U2. Okay. So same thing I will do, but U2 will be 20. That's the only difference. Focus is going to be the same. The only difference is U2 is going to be minus 20. So minus 1 by 15 plus 1 by 20, you will get 60 centimeter. Okay. So now I have my image distance for the first case. When the object was at 40, I have my image at minus 24. When the object is at 20, I have my image minus 60. So these two, if you subtract, you will get how much the image shifted, right? What is happening here? This is the lens. Object was at 40, it got shifted to 20. Image was at 24, it got shifted to 60. So how much is the difference? 60 minus 24. So that if you do, you will get 36 centimeters. Are you understanding? Yes? Is this clear to all of you? Can I have some fire in the chat if this is clear? Yeah? Yes, yes. Can I have some fire in the chat if this is clear to all of you? Have you all liked the video? Please do subscribe to our channel. Let's quickly make it 30k. Okay, we already have 27 point something. After this video, let's make it 30k. Okay? Yes. Thank you, Crazy X, for listening sincerely. Yes, understood? Yes, Sanjana, Yeha, Sapphire, Himnish. Yes, I know RCB won. I want you to win for physics tomorrow. Okay? Yes. Students, please go tell your friends the class is happening. The class has already started. Okay? Yes. Okay. The two nuclei having mass numbers in the ratio of 8 is to 125. What is the ratio of their nuclear radii? Okay? Okay? So I have to find out the ratio of their nuclear radii. What is the formula? Very famous formula. R is equal to R naught A raised to 1 by 3. But here we have 2. Okay? The ratio is 8 is to 125. So this is basically A1 is to A2. A1 is 8. A2 is 125. Alright? Now, what will R1 by R2 be equal to? R1 by R2 is definitely going to be equal to A1 by A2 but raised to 1 by 3. See, R0 is a constant, so you can just ignore it. So what I'm going to do is R is proportional to A raised to 1 by 3. So I'm going to take R1 by R2 and A1 by A2. Okay? Alright. So what is A1 and A2? 8 and 125. So 8 by 125 raised to 1 by 3. How much is it? 2 by 5. So the answer is going to be 2 by 5. 2 is to 5. Okay? These are all simple. You can definitely score 3 marks for this. Right? Yes? No? What is happening? Yes? Is this clear? Quickly, we'll just finish this and quickly move on to 5 mark numericals and 5 mark theory also I will discuss today. Oh yeah, we've already done. So the ratio is 2 is to 5. Okay? Now we're going to start with 5 mark numericals. Students, all of you come back. All those who wanted 5 mark numericals, please tell your friends we're going to start 5 mark numericals. So after 5 mark numericals, we will discuss 5 mark theory as well. Okay? Is this fine? Yes, yes, no, yes. Can I have some energy in the chat? Yes, Sapphire Soul. If you failed in physics, this is your chance to write it again, dear. Okay? Done? Yes? Yes. So before we start 5 mark, can you quickly like, subscribe? No? Show us some love. Just like, we show you all our love. Yes? Okay, let's start. First question. Okay, all of you ready with full energy? Okay, I'm also ready. First question. A 800 picofarad capacitor is charged by a 100-volt battery. Okay. After some time, the battery is disconnected. The capacitor is then connected to another uncharged 800 picofarad capacitor. What is the electrostatic energy stored in the system after connection? Okay. Okay. Yes. Okay. So did you all understand the question? Is it clear? Shall we start? Yes. So first thing, what is given? The capacitance C is 800 picofarad is given to you. Every time you do a question, you have to convert it into SI units. So it's going to be 800 into 10 raised to minus 12 farad. Okay. And it is charged by a battery of voltage 100 volts. So V is 100 volts. Yeah. So now how will you find out the potential energy or electrostatic energy? U is equal to half CV square. So half into 800 into 10 raised to minus 12 times 100 square. Direct substitution. Okay. So you will get 4 into 10 raised to minus 6 joules. Okay. So I have solved the first part. So I have a 800 picofarad capacitor which is charged by a 100 volt battery. So I found out the energy of that. One part is done. Now what happens after connection? Okay. After this, the battery is disconnected. Alright. So even if the battery is disconnected, the charges will always be there on the capacitor. Okay. So let me find out the amount of charge on the capacitor. Since I have capacitance, I have voltage, I can easily find out charge by just multiplying these two. Isn't it? So it is just 800 into 10 raised to minus 12 into 100. 8 into 10 raised to minus 8 coulombs. Okay. Now, what will my total capacitance be? Yes. So, see, what is happening in the question, you should understand this. There is a 800 picofarad capacitor. This capacitor is then connected to another 800 picofarad capacitor. Now you have two 800 picofarad capacitors. So, what is the total capacitance? 800 plus 800, which is 1600 picofarad. Okay. So, I first found out the energy and the charge with one capacitor alone. Now, I'll find out all of this with two capacitors. Okay. Okay. Is this fine? So, first I found out the energy U and charge Q with one capacitor. Then according to the question, they say there are two capacitors. So, now I will find out all of these with two capacitors. So what will I do? I don't know at what voltage it is connected to. There are two capacitors. Initially, the one capacitor was connected to 100 volts, isn't it? But now two capacitors are there, but I don't know to what volt it is connected. So let's calculate that first. So Q is the charge, which is 8 into 10 raised to minus 8. It's not going to change. And total capacitance is 1.6 into 10 raised to minus 19. So 50. The voltage is 50. So initially one capacitor was connected to 100 volts. Now two capacitors are connected to 50 volts. Is that clear? So now find out the energy. Simple. Easy peasy. How will you find out the energy? Half CV square. What is the C? Total capacitance 1.6 into 10 raised to minus 19. And what is V? 50 square. So I have my final energy stored is 2 into 10 raised to minus 6. Okay. Is this clear to all of you? So you have to understand the question first. Okay. Yeah. What should you do? First, you have one capacitor connected to 100 volts. You find out the energy of that. Then you find out the charge of that. And then you have two capacitors connected to some volts. So you have to find out the voltage first. Then find out the energy. Is this clear? Yes. Yes. So usually if parallel or series is not mentioned, you can just add them. It has to be mentioned. It will be mentioned in your exam. Okay? Okay? Is this clear? Fine, fine. Yes, can I have some fire in the chat if you all have understood this question? Some fire, quickly, quickly. I can't see you students, so please let me know. Yes. Okay, clear. Okay, Amulya. Hi, Amulya. Amulya was there in yesterday's class also. Okay. Yes, Himnish, Ganavi, yes. I'm happy to see my students, being there in every class. Okay, next question. Next question. Okay, next 5-mark question. Next 5-mark question, what is it? Two charges, Q1 and Q2. Okay, Q1, okay, I'll draw it so it's easier for you. So, two charges, okay, Q1 and Q2. These are located 16 centimeters apart. Okay, Q1, Q2 are located 16 centimeters apart. Okay, at what points on the line joining the two charges is the electrical potential zero? So here you have to find out at what points the electrical potential is going to be zero is the question. Do you understand the question? Two charges are located 16 centimeter apart. We have to find where on these the charges the potential is going to be zero. Okay? Alright. Yeah. So what we will do? First thing, write down the formula. The only formula for potential we know is V is equal to 1 by 4 pi epsilon naught Q by R. Isn't it? That is the only formula for potential we know. Yeah? V is 1 by 4 pi epsilon naught Q by R. Let's substitute. So what we are going to do is, we are going to first find out the potential because of charge Q2. Okay. So let's say, first we will, what shall we do? Okay, let's put this. So let's put a point somewhere in between. Okay. So let's put a point somewhere in between. I'll just make this point X. Okay. So now what I will do is, if this much is X, then this is going to be 16 minus X. Okay. So 16 I will just take it as R. So if this is X, the rest is going to be 16 minus X. Okay. So first I will find out the potential because of Q2, which is going to be 1 by 4 pi epsilon naught is what? 9 into 10 raised to 9. Into, what is the charge? 5 into 10 raised to, this is Q1. Okay. 5 into 10 raised to minus 8 divided by X. So what am I doing? I know I have to draw, I have to be better at drawing, no? All your other teachers draw very well. I will try to improve. Q1, Q2. This is the point where, imagine this is the point where the potential is 0. Okay. This point is at a distance X and this full thing is R. Okay. So now I'm going to find out the potential because of Q1. So 9 into 10 raised to 9 into 5 into 10 raised to minus 8 divided by X. So according to the question, let's just make this as X because it's for Q1. Let's say this is X. This is going to be X, R minus X. Now V2 due to Q2 will be 9 into 10 raised to 9 into 3 minus 3 into 10 raised to 8 divided by R minus X. So the first charge is at X. The second is at R minus X. Is this clear? Now what I will do? What will the total potential be? From both the sides, the total potential will be V1 plus V2. V1 is the potential because of charge Q1. V2 is the potential because of charge Q2. Total potential will be V1 plus V2. So you just add these two. So what do you have? 9 into 10 raised to 9 into 5 into 10 raised to minus 8 by X plus 9 into 10 raised to 9 into minus 3 into 10 raised to minus 8 divided by R minus X. R was 16 centimeters, which is 0.16 minus X. Is this fine? Now you just have to do basic math. The common terms you can eliminate. Why? Because it is equal to 0. Why is it equal to 0? In the question they say the two charges, the point where the electric potential is 0. So because this is 0, I can equate these to the other side. So what remains? 10 raised to minus 8 is also there in both sides. So I can equate that. So what remains? 5 by X minus 3 divided by 0.16 by x. So what will this be? 5 by x will be equal to 3 by 0.16 minus x. So now if I do the math, I will get x as 0.1 meters. I just cross multiply. 5 into 0.16 minus x is equal to 3x. Okay? Yes. So 0.8 is what? 0.8 minus 5x is 3x. So x will get 0.1. Did you all get 0.1? Did you all get 0.1? Yes. Yes. Himnish got 0.1. Very good, Himnish. Yes. Very good. But that is not the end of the question. Yeah. What is the rest? The electric potential will also be 0 at a point P1. External to the line joining. See, the question clearly says the electric potential will be 0 at 2 points. The first point is at 0.1. Now, where will the second point be? We are going to assume that it is at a far off point. Okay. So, the second point is going to be somewhere here. Okay. So, here it is 0. We proved that. Now, we have to find out the second point, which is at a far off point. So, isn't it going to be r plus some value? Yeah, P is going to be r plus some value. So I will take this as x itself. So that is how you get 1 by 4 pi epsilon naught 5 into 10 raised to minus 6 0.16 plus x. And the other one will be 1 by 4 pi epsilon 0 minus 3 into 10 raised to minus 8 by x. Is this fine? Again, what you will do? You will just add them to find the total potential. V dash is V1 plus V2. You take away all the unwanted terms. You add them. You will get 24 centimeter. Same step you are repeating. Okay? Same step. Is this fine? Yes? No? Same step. So, the only thing is, first you have two charges. First you find out the point at the center. So, you have to take it as x and 16 minus x. Then you have to find a point. If these are the two charges, find a point here. So, 16 plus x. Okay. Is that fine? What is your question, Anita? What all do you want to know? Is this fine? Sapphire Soul says it's fine. Yes? I'm not explaining the second part because it's the same thing. The only thing is I find out the next point. Okay. Shreya says she got it. Okay. Great. Okay. Great. Great. Others? Hi, Archana. Okay. Yes. Next question. A parallel plate capacitor has air between its plates. Okay. So, Sapphire Soul has asked me if it's necessary to write in meters. Yes, all the answers should be in your SI unit. Okay. It's always good to write your answers in your SI units. Alright. So, to be on a safer side, you write in the unit which you get and its SI unit as well. Okay. Yes, these are all NCRT problems here. These are all 5-mark NCRT problems. See, you write it in centimeters and meters. Then you don't have to worry if they will reduce marks or not. Okay, next question. A parallel plate capacitor has air between its plates. Okay, so there are two plates. It has air between the plates. The area of this plate is 6 into 10 raised to minus 3. The area of this plate is also 6 into 10 raised to minus 3. The distance between these two plates. This distance is how much? The length of this distance is 3 millimeters. That is the question. Okay. Okay. So there are parallel plates. Area is given. Distance between them is given. We have to find out the capacitance. So let's look at the first part of the question, which is Calculate the capacitance of the capacitor. Formula for capacitance, C is equal to epsilon naught A by D. All these three quantities we know. What is epsilon naught? 8.85 into 10 raised to minus 12. Area we know, 6 into 10 raised to minus 3. Divided by distance, 3 millimeters. You should convert it into meters. So it will be 3 into 10 raised to minus 3 meters. If you do the math, you will get 17.7 picofarad. Quickly, can you solve it? Direct substitution. So this is only one part to the question. Yeah? Yeah, somebody already got it. Yeah, Sapphire Soul. Yes, very good. Very good, very good. 17.7. Good. Now, what is the second part of the question? If this capacitor is connected to a 100 volt supply, calculate the charge stored on each plate. Okay. So, now this capacitor is connected to 100 volt supply. I have to calculate the charge on each plate. Okay. How will I do that? Very simple again. Charge is C into V. So what is charge? 17.7 into 10 raised to minus 12. So if you go wrong in part A, you will go wrong in part B also. Be very careful. 17.7 into 10 raised to minus 12 into, it is connected to 100 volts. So into 100, you will get 1.77 nanocoulombs. Okay? Okay? Fine? Yes? No? Are you all solving? Getting it? Yes? No? Yes. Shall we move on to the next question? Yes, important derivations we will do, students. See, I'm not a robot, I'm a human being. So after these numericals, we will do important 5 markers. Okay? Yes? 5. Okay? Yes. Let's move on to the next question. Okay. Hey, what happened? Next question. A copper wire has a diameter. So there's a copper wire. The copper wire has a diameter of 0.5 millimeters. Okay. It has a resistivity of 1.6 into 10 raised to minus 8 ohm meters. Diameter, resistivity is given. What will be the length of the wire to make its resistance 10 ohm? What will be the length of the wire to make its resistance 10 ohm? How much does the resistance change if the diameter is double? So I will take one step at a time. So I'll solve the first part first. What will be the length of the wire to make its resistance 10 ohms? So what all are given to you? D is given. So first thing, D is 0.5. So how will I find out what is the relation between resistance and resistivity? R is equal to rho L by A. But I don't have area. So how do I find area? Area will be pi r square. I don't have radius, so it would be pi d by 2 square. Okay. So when you do pi d by 2 square, this will be 3.14 into, how much was d? 0.0005, the whole divided by 2 square. So when you do the math, you will get area as 1.9363 into 10 raised to minus 7. Now simply substitute in my formula. What is the term that I have to find? I have to find out L. So I will rearrange this. RA by rho is equal to L. Isn't it? And then I will just substitute. How much is my resistance? How much is my resistance? 10 ohm. Okay. So 10 into my area is 1.93635 into 10 raised to minus 7 divided by 1.6 into 10 raised to minus 18 should give you 122.34. Okay? Yes? Are you all getting it? Are you all getting it? Yes? So that is only the first part. So I found out that the length is 122.34. So that is the new length. Important to write it as picofarad? No, you can write it as C itself. Okay. Now, what is the second part? How much does the resistance change if the diameter is doubled? So, how will I do that? See, this is the formula. R is equal to rho L by A. So, how much the resistance will change if the diameter is doubled? So, what is A? A is pi d by 2 square. So, if the diameter is doubled, what happens? Won't area become 4 times the initial area? This will become d 2d by 2 square, which is going to be 4d square by 2. So, this d square by 2 will go. So, A will basically become 4A. Right. Okay. So, when the diameter becomes double, area will become 4 times area. So, what will resistance be? Inversely proportional to 1 by A. See, how did I get that? R is equal to rho L by A. So, if I take rho and L as a constant, then R is proportional to 1 by A. Okay. So, R is proportional to R by 4. Why? Because if area increases by 4, resistance should decrease by 4. Because it's inversely proportional, isn't it? See, if it's directly proportional, when one increases, other also increases. But if it's inversely proportional, if area increases by 4, resistance should decrease by 4. So that is how you get R dash is R by 4. Now what is my resistance? 10. So 10 by 4 is 2.5. Is this clear? Yes? Okay. So very simple. I mean, it's not that simple, but I hope it's simple now. So this is going to be pi 4d square by Is this fine, students? Yes? You have two parts to the question. You had to first find out the length and then find out the resistance. You want me to repeat the second part? Sure, I can repeat the second part. So what happens is, see, what does it ask you? They're telling you diameter is doubled. Okay? So when diameter is doubled, what will happen? What is area? Pi r square. Now if radius is not there, it is diameter by 2. Pi d by 2 square. Alright? Now diameter is doubled. So what happens? Diameter will become 2d. So this will be 2d by 2 square. Okay? Now let's square it. So this is going to be 4. 2 square is 4. And then d by 2 square, I'll put it as d by 2 square itself. Okay? Now, pi d by 2 square is a. So, isn't this going to be 4a? This term and this term, I'll take it as a. So, it is going to be 4a. So, can I say a dash is equal to 4a? Isn't it? See, what I did is I just took this 2 outside. So, it becomes 4 outside. Why did I do that? So that I can write pi d square by 2 as a. So a dash will become 4a. Okay. Now we already also know that r is proportional to 1 by a, inversely proportional. So if area becomes 4a, shouldn't resistance become resistance by 4? Do you understand that? See, they're inversely proportional. So r is proportional to 1 by a. So 4r is proportional to area by 4. Okay? Yes? Is this fine? Since it's inversely proportional, when resistance increases by 4, area should decrease by 4. Or area increases by 4, resistance should decrease by 4 since they're inversely proportional. So since they're inversely proportional, what happens to area? Area increases by 4. So resistance should decrease by 4. That's why it becomes R by 4. Is this fine? Someone had asked me, I don't remember the name. Can you tell me if this is fine? Yeah? Yes? No? In this video, we will do more than numericals. After this, I'll discuss all the 5-mark important questions. Is this clear? Can I have some response? Okay, yeah. You had asked me, right? Okay. Okay. Very good. Next question. An object of size 3 centimeter is placed 14 centimeter in front of a concave lens. Okay? This is a concave lens. This object is of size 3 centimeter. It is placed at a distance of 14 centimeter. Okay, this much is given to you in the question. An object of size 3 centimeter is placed 14 centimeter in front of a concave lens with a focal length of 21 centimeters. Focal length of 21 centimeter. Describe the image produced by the lens. What happens if the object is moved further away from the lens? Okay, so do you understand the question? Do you understand? Yes? So the image, you have to describe how the image is going to be produced by the lens and what happens if the object is moved away. Yes? Did I get cut off, students? The Wi-Fi just... Yes, I'm live, right? Yeah. Okay, sorry for that. Okay, so an object of size 3 centimeter is placed 14 centimeter in front of a concave lens with a focal length of 21 centimeter. Describe the image produced by the lens. What happens if the object is moved further away from the lens? Let's do it. So 1 by f is equal to 1 by v minus 1 by u. So what is my focal length? Minus 21 centimeters in front. What is my object distance? Minus 14. Why is it minus? Because both are in front of the lens. So many times I've explained, right? So what is 1 by f going to be? 1 by minus 21. Because if you have a lens and it's in front, okay? If the measurement is towards the left, what happens? It is negative. Yes? Am I live? Students, can you just let me know if my audio and video is clear? Yeah? Okay. So 1 by f is 1 by minus 21. And this is going to be equal to 1 by v, we don't know. Minus 1 by what is u? 14 minus 14. So if you do the math, what will you get? 1 by v is equal to 1 by minus 21 minus 1 by 14, which is equal to minus 2 by 42 minus 3 by 42. You will get v is equal to minus 42 by 5. How much is it going to be? Minus 8.4 centimeters. Are you all getting it? Yes? Is my voice stuck? Can someone let me know? Yeah, very good. Sapphire Soul has got minus 8.4. Yes, superb, superb. Are you not able to hear me? Can you let me know in the chats? Echo, theory questions I will do. Okay, so now we've answered the first part. Describe the image produced by the lens. Now, what happens if the object is moved further away from the lens? So, the image is minus 8.4. So, it's obviously a virtual image. It's upright, it's reduced in size. What happens if it's moved away? What will happen if, I've already taught you this before, if the object moves further away from the lens, if this is the lens, object moves away, image will move closer. Okay? It'll just move closer. It'll always be virtual, upright and diminished itself. So there are two parts to the question. Okay? First part is where the image is, then the nature, then what happens if it moves away. Is this fine? Yeah? Okay. Next question. Theory questions I will do, dear. Is it lagging? There was a small power fluctuation here. That's why. Okay. A galvanometer having a resistance of 50 ohm requires a current of 10 milliamps to give full scale deflection. How much resistance is required to convert it into an ammeter with a range of 10 amps? Additionally, a galvanometer coil of 50 ohms resistance shows full scale deflection for a current of 5 milliamps. How will you convert this galvanometer into a voltmeter with a range from 0 to 15 volts? That is the question. Okay? Yes? Alright? Students, can you quickly let me know if my audio and video is clear? If it's clear, can you all put some clear in the chat? Because some of them are saying that it's not clear. Now it's clear. Okay, thank you, Harsha. Okay. Yes. Super student, super energy. Okay. I really like all of your energy and the way you're solving the questions. Very good, very good. Super energy. Yes. Uh, Not clear and clear both are there. So what should I do? I should go with the majority. Okay. Okay, Hibnish. So is the question clear? I hope the question is clear. So now to convert a galvanometer into an ammeter, what should you do? You should take a resistance, a shunt, okay? A resistance and connect it in parallel to the galvanometer. Right, that's how you convert it. So what is the formula? S is equal to GI divided by I minus IG. What is G? 50 ohms. What is the current I? 10 milliamps. It is going to be um yeah, so it's going to be 100 into 10 raised to minus 6 divided by again 10 minus 100 into 10 raised to minus 6. So what you will get? You will get 5 into 10 raised to minus 4. Now, see the equivalent circuit is shown to you here. So what is it going to be? There's going to be a galvanometer. It's going to move at a current of 5 milliamps. Okay. And the voltage is going to be 15 volts. Yes. Okay. So what I will do? I will do Ohm's law. What is Ohm's law? V is equal to IR. So what is the total voltage? Total voltage is 15 volts. The maximum voltage it can measure is 15 volts. Okay. 15 volts. So 15 volts is going to be equal to 15 is going to be equal to what is the current? I got 5 into 10 raised to minus 3 times. The total resistances are going to be the resistance of the galvanometer and the resistance of the shunt, which is 50 plus S. So you will get 2950. Okay? Okay, students? Is this clear? Can you let me know? Are you getting this answer? Students, we are at 28K subscribers. Let's quickly make it 30K. Yes? Quickly. Yes, I know you're all easily capable of doing it. Let's make it 30K subscribers quickly. Okay. Next 5 marker. Important question. Next 5 marker. Okay. Hello, Ganga. Yes. A rectangular loop. Okay. You can look at the picture. There's a rectangular loop. The rectangular loop has sides. One side is 25 centimeter and the other side is 10. Okay. So there's a rectangular loop. One side is 25 centimeter. The other side is 10 centimeter. And this is carrying a current of 15 amps. Okay. This is carrying a current of 15 amps. This is placed with its longer side parallel to a long straight conductor. Okay. So again, my drawing is bad. Let me make this longer. So 25 centimeter and 10 centimeter. Alright. This is placed parallel to a straight conductor. So there is a straight conductor here, parallel. Okay. And these are at a distance of 2 centimeters apart. Okay. Carrying a current of 25 amps. This is also given that the parallel wire is carrying a current of 25 amps. We have to find out the net force on the loop. Alright? Yes? Yes. 5 mark important questions we will do, students. I've been telling you this from the beginning of the class. We will do that. So how will we solve this? This is also a 5 mark question. Okay? So what are we going to do? First thing, we'll take this one, this rod. Okay? What is this rod? This rod is PQ. PQ is parallel to RS. Do you see RS? Yeah, you see RS. PQ and RS, they are the same, aren't they? So PQ and RS are both going to be equal to 25 centimeter. Yeah. Similarly, QR and PS. QR at the denominator, PS at the numerator. They are both also going to be equal to 10 centimeters each. They are going to be equal. Now R1, which is the distance from the wire to the loop, is 2 centimeter, is given. R2 is 12 centimeter. Do you see what R1 is? R1 is this distance, the distance from the extra parallel wire to the loop. R2 is the distance from the extra parallel wire to the end of the loop. This full thing is R2. Okay? R1, R2. Is that fine? All these are given to you. Now, simple formula for parallel loop. Parallel loop, what is the formula? F is equal to nu IIL by 2 pi R. What is nu? 4 pi into 10 raised to minus 7 times. What is the current on the first loop? 15. Current on the second loop? 25. What is the length between them? 0.25. The whole divided by 2 pi into 0.02. What is 0.02? The distance between them. R1. L is the length of the conductor. Is this fine? Yes. Yes, Swati is saying, guys, like Mardi. Yes, guys, like Mardi. All of you, please, like Mardi. Is this fine? Direct question, students. So you will get 9.37 into 10 raised to minus 4. So when you see such complicated questions, you don't have to be worried. Look at whatever is asked. You only have to find out force. What is the formula for force between two parallel wires? Nu IIL by 2 pi R. So what is I? I is the current on the wire. The other I is the current on the loop. L is the length of the conductor, which is 25. And R is the distance between them, which is 2 centimeters. Okay? Yes? Yes? No? Can I have some response? Is this clear, students? Okay? Yes. Next question. Next question. An electron beam passes through a magnetic field of 2 into 1 second. Yeah, okay. An electron beam passes through a magnetic field of 2 into 10 raised to minus 3 Weber per meter square. An electric field of 1 into 10 raised to 4 voltmeter, both acting simultaneously. Yes. You're welcome, Suma. The path of the electron remains undeviated. Find the speed of the electron if the electric field is removed and the radius of the electron's path when the electric field is absent. Okay, so we have to find out speed of the electron, radius of the path. Okay, no problem, very easy. What is the formula for speed of electron? Electric field by magnetic field. What is the value of electric field? 1 into 10 raised to 4. What is the value of magnetic field? 2 into 10 raised to minus 3. So if you just take the ratio, you will get the speed of the electron. Okay. Then you have to find out the radius of the path. So how will you do that? MVR. MVR is equal to, if you do the math, you will get R is equal to MV by EB. The radius is mass times velocity divided by charge of an electron times magnetic field. So all of these terms are given to you in the question. V is 5 that you already found. So that is why I always say make sure part A is perfectly correct, because you usually have to use part A for part B. Isn't it? So if part A goes wrong, then you will not be able to do part B. Okay? Yes? Yeah. So it is 9.11 into 10 raised to minus 31 into 5 into 10 raised to 6 divided by the charge of 1 electron times the magnetic field. You will get 1.42 centimeters. Okay? Clear? Clear? Yes? No? Derivatives I will do, dear. We will look at all important 5 markers. After we finish this, in another 5 minutes, we'll finish this. Okay? Yes? Yes, students. Super. Yeah, next question. Convex lens question. Okay? So, two convex lenses. Okay? Two convex lenses. 20 centimeter and 30 centimeter are kept in contact. Okay, they're in contact. Okay? The equivalent focal length of the combination is, so F1 and F2. F1 is 20, F2 is 30. So equivalent combination is what? 1 by F is 1 by F1 plus 1 by F2. So you will get 0.12. Very easy. I found that out. The power of the individual lenses. How will you find power? Power is 1 by F. So power of the first lens will be 1 by 20. Power of the second lens will be 1 by 30. Every time it should be converted into meters. That's why you have 0.2 and 0.3. Okay? Power is always 1 by 0.2 and 1 by 0.3. So you will get the power of the first lens and the second lens. So what will the power of the combination be? Power of the combination will be 1 by F total, which is 1 by 0.12. So I have that also. Okay. Now I have solved 3 parts. Equivalent focal length. Power is also solved. What is next? A double convex lens is made from glass of refractive index 1.55. Both surfaces have the same radius of curvature. What should be the radius of curvature if the focal length is 20 centimeter? Okay. So the question is, what should be the focal length if the radius is, what should be the radius if the focal length is 20? The very famous, very important lens maker's formula. So 1 by F is what? Mu minus 1. 1 by R1 minus 1 by R2. Okay. But you have to know if R1 and R2 are positive or negative. That you have to learn. Okay. Now for a double convex lens, R1 is always positive, R2 is negative. Okay. So what you will do? You will just substitute the values. R1 is positive, R2 is negative. So it becomes 1 by R plus 1 by R, which is 2 by R, which is going to be 1.1 by R. Now, it's also said that the new focal length is 20. So, this is going to be 0.20. So, that's how I get this formula. 1 by 0.20 is equal to 1.1 by r. Okay? Alright? Yes? Yes? No? Okay, students, this is a focal length question. Next question. The angle of minimum deviation for a prism of angle 60 degree is. The angle of minimum deviation for a prism of angle A is 60 is how much? So how will you do that? First thing, the question is to find out refractive index, right? So how will you find out the refractive index? How will you find out? Quickly find out the refractive index. So it is sine A plus D by 2 divided by sine A by 2. Yes. So to substitute, what is A? 60. What is D? 40. So it is going to be 60 plus 40 by 2 times 60 by 2. Okay? Yes? Quickly tell me, are you all getting what is the answer? Are you all getting 1.53? Yes, Ashia, I will do it. I'll do all the 5 markers now. Okay? Yes? Done? 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 Okay, last question. And then we are going to discuss 5 markers. 5 markers we are going to discuss. Last question. Okay. Use Bohr's model. Calculate the speed of the electron and the orbital period in a hydrogen atom for levels n is equal to 1, 2 and 3. So first thing, speed. What is the formula for speed? V is equal to 2.186 into 10 raised to 6 by n. And what is the radius? Rn is n square into 0.529 times 10 raised to minus 10. These are all constant. You can just learn these. Time period is what? 2.186 into 10 raised to 6 by 1. R1 is 1 square into 0.529 into 10 raised to minus 10. T1 is 2 pi R1 by V1. Now do the same thing for n is equal to 2 and then n is equal to 3 and then you will get the final answers. Okay? Yes? Is this clear? Okay? So those are some important numericals that I have given you to practice for your second exam. Okay? So you will have similar numericals for your exam. Now what we are going to discuss is we are going to discuss 5-mark theory questions. Okay? The most awaited 5-mark theory questions. Okay? So I'm not yes. PDF I'll send. Okay, after the class I'll send the PDF. 5-mark theory questions, let's start. Do you have the energy for 5-mark theory questions? Students, we are at 28,000 subscribers. Can you quickly, let's make it 30. Quickly, students, your support is what means a lot to us, no? Only if you support us, we can keep doing this. We spent late nights working all of this material for all of you, for your love, right? For your support. So quickly, can you all go subscribe and like? Yes? Full support? Let's make it 30. Okay, let's start. Yes, Shashank has put fire. Where are the others? Nobody else is there in class. Hello. Shashank made 50 subscribers yesterday in class, it seems. Wow. Make it little more today so we can hit 30K. Hey, numericals is what I just finished. Someone's asking me for numericals. That I just finished. Okay. Yes. Hi, mix with fun. For all those who are asking where you can find the PDF, you can find the PDF in the description. Not now, but after the class, you go to the description. There will be a link to PDF. Okay? Is that clear? Yes. Ma'am can't see our chat. I can see your chat. Okay, let's start. First question. Derive the expression for electric field at a point on the axis of an electric dipole. This is a frequently asked 5-mark question. Okay, to derive the electric field on the axis of the electric dipole and at an equatorial region. These two. Okay. Okay, so what should you do? You have two charges. Okay, the charges are plus q and minus q, and they are separated by a distance of 2a. Okay, you have to find out the field at a point P. Okay, P is a point on the line at a distance r from the center. So if this is O to P, the distance is r. Alright, now what will you do? You will just find out the electric field at plus q, electric field at minus q, add them, E plus q plus E minus q, you will add them. Okay, and how will you take the distance? This much is A, this is also A, so it's going to be R minus A and R plus A. You understand that? That is very important. So if this is P, this is plus Q, this is minus Q. Yeah, minus Q. So this much O, A, this is R. Okay, so that is how you get this distance is going to be R minus A, and this full distance is going to be R plus A. So due to minus Q, the distance from P is going to be R plus A. From P to plus Q will be R minus A. Okay, and then yes, cooked up live was supposed to be at 7, but then I just shifted it back. Okay, and then you simply do the math, you will get it. Okay, I'm not going to solve the whole math because we have lots of portions to complete. All the steps are given after this class. You can just go through this. I'll tell you how to do each of these, but we will not look into details. Next, derive the expression for electric field at a point on the equatorial line of an electric dipole. So that's the other one was axial. This is equatorial. Equatorial is like a point on top. So let's say the point is P. So here, according to my derivation, this is going to be R. So this is going to be A. So what is the distance between the charge and the point going to be? R square plus A square. Square root of R square plus A square. Isn't it? Pythagoras theorem. Okay. So what you will do? You will find out the electric field because of plus Q. Electric field because of minus Q. Okay. You will find both the electric fields and then you will add them. But you have a cos theta term. Why do you have a cos theta term? Because here the electric field is at two angles. You can see sin theta terms will cancel out. The cos theta terms will remain. Okay. So E1 cos theta and E2 cos theta will remain. The sin theta terms will cancel out. Okay. So what will it become? Both the charges added together. Q divided by 4 pi epsilon naught 2aq r square plus a square the whole raised to 3 by 2 p cap. Now this a cos theta, I have put all the steps in detail here, so you can actually try this by yourself. A cos theta will be r divided by r square plus a root of a square. How? Again, cos theta is opposite side by adjacent side by hypotenuse. Sorry. Adjacent side by hypotenuse. And when you do the math, you will get this. This is the second very important question. Okay. Hi Shreyas. Happy? Alright. Okay. Next question. State Gauss law in electrostatics. Okay. The question is to state Gauss law in electrostatics. Derive an expression for electric field at a point due to a uniformly thin straight wire using Gauss law. Okay. Yeah. So derive an expression for state Gauss law in electrostatics. Derive an expression for electric field at a point due to an infinitely long. So this is a figure. You have a long wire. Okay. The length of the wire is L. The electric field is pointing outwards. Okay. So what is Gauss law in electrostatics? The total electric flux through an imaginary surface is proportional to the total charge enclosed by the surface. Phi is Q by epsilon naught. We have discussed that. We have already discussed that. Okay. Now, what is the next thing that we're going to do? We are going to see that for full marks, for all 5 marks, for every derivation, you have to write a small explanation. Okay. I've given that you here. There's a small explanation. For all 5 marks, I've done that. Okay. Shreyas got 55 marks because of me. Thank you, Shreyas. Okay. Yes, some of these questions will definitely come tomorrow. Okay, so how will we find phi? Phi is E del S cos theta. Now theta is 0 because E is normal to the surface. It becomes E del S. Now what is the del S? Del S is basically the 2 pi RL. It is the surface. So it is 2 pi RL. We also know from Gauss law phi is Q by epsilon naught. What is Q? Q is lambda L because it is the total charge enclosed by the surface. So instead of here I will substitute lambda L by epsilon naught. Now what I will do? I will substitute everything. What is phi? Phi is 8 pi 2 RL. So here I will write this is equal to E 2 pi RL. Okay. So what is E going to be equal to? Lambda divided by 2 pi epsilon naught R. L and L will cancel. Okay. Yes. Okay. Next very important question. Derive an expression for the electric field at a point due to a charged spherical shell using Gauss law. Okay. So what is the figure here? You have two surfaces. The inner one has a radius of r. The outer long one has a radius of small r. Okay. So the inside there is a charge q which is enclosed. Outside it is a big charge. Okay. So phi is E del S cos theta. Phi is E del S. I'm not going to explain every step, okay, because then I can't finish it. I want to give you all 5 important mark questions and I'll finish the class soon. Alright. This is a sphere. So obviously the area is 4 pi r square. So phi is going to be q by epsilon naught. Same steps. The only difference there it was a cylinder 2 pi rl. Here it is a sphere 4 pi r square. Same steps. Okay. So I want you to relate and study. Okay. Yes. Next question. Obtain an expression for the electrostatic potential at a point due to an isolated point charge. How will you do that? So first thing, what is the formula for electrostatic field? E is equal to 1 by 4 pi epsilon naught q by x square. Yes? Okay. Now what is happening here? You have two charges. One charge you are bringing from infinity. Okay. Now the work done to bring that from infinity is going to be E dot dx, which is E dx cos 180 minus E dx. Now total work done will be total work done in moving it plus the charge from infinity to the point. So W is going to be dW, which is E minus dx. Okay. Substituting what is dx? 1 by x square. And that finding the integral. Okay. Okay. Gopala Krishna, I just did one shot numericals. Okay. Please watch the recording. Okay. Next question. Obtain an expression for potential energy of an electric dipole placed in a uniform electric field. Another important question. All the explanation I have given, I will just explain how to do it quickly. Okay? Yes? Students, important numericals I have done in this video itself. Okay? Please go watch the recording after the class. So what is V? Q by C? So many times we've discussed that. Now what we're going to do? We're going to do work done. Work done is V times dq. Okay. So I will just do all the math. You will get this. Now work done is from initially from 0 to a charge Q. That is why 0 to Q. Okay. Yes. So when you solve it, you will get W is equal to Q square by 2C. I want you all to take the PDF and solve. All the steps are there here. Okay. Now from this, work done is always stored as potential energy. Okay. So work done is always stored as potential energy. So this would be Q square by 2C. Okay. Now, if you just substitute Q is equal to C by V, you will get U is equal to half CB square. Alright. Yes. Okay, next very important question. Define energy density of a charged capacitor. How is energy density related to electric field? So what is energy density? It is the energy stored in the electric field between the plates of the capacitor. That is energy density. And the formula is U is equal to half epsilon naught E square. Okay? Okay, next question. Arrive an expression for equivalent EMF and internal resistance of two cells connected in series. So you have to know connected in series and connected in parallel for both. Okay? You have to know the derivation for both series and parallel. So all the steps are mentioned here. So you just have to do what? V is equal to E minus IR is the general formula. So you have to keep substituting that for VA and VB. Okay? All this in detail I have done in my previous videos. You can go refer that also if you want to. All the steps are there. Okay? And you will get E equivalent is equal to E1 plus E2. R equivalent is R1 plus R2. Students, those who want to know how this is done, you can just watch the past package. Okay. Next question. Derive an expression for equivalent EMF and equivalent internal resistance when two different cells are connected in parallel. So again, all the steps are there. But only difference in parallel, current is I is I1 plus I2. In series, V was V1 plus V2. Okay, two things that you need to remember. In parallel, I is I1 plus I2. Voltage is the same everywhere. But in series, voltage is added. Current is the same everywhere. If you know that one step, you can actually do this. Okay. Okay. Super. Yes. Ma'am, PDF, it's there. It will be uploaded. Next question, deduce the condition for balance of a Wheatstone's bridge using Kirchhoff's law. Okay? Using Kirchhoff's law. So, main important thing is figure. Figure is very important. And then what is the balancing condition? All the currents have to be balanced. So, you have to look at the loops. Okay? So, this also very clearly I have explained in the last video, past package video. Okay, here also I put all the steps. You just have to prove that the resistors R1 by R2 is equal to R3 by R4. So every derivation, it's good if you can write a small explanation in front of it as well. Okay, very good. Super. Next question. This is like a very famous question. It's asked so many times. Deduce the expression for magnetic field on the axis of a current carrying loop. Okay. So this question as well I have explained very clearly in my past package video. Okay. So here also I have put all the steps for those who want to refer it. Alright. Next question. Derive an expression for force per unit length of two infinitely long thin parallel straight conductors carrying current and hence define ampere. Okay. So here what do? You have two conductors. Okay. So between these two conductors there is a force. So you have to find that out. So B is equal to nu 0 I by 2 pi r. Now this we looked at this formula when we looked at the numerical. Force is BIL sin theta. Force 2 will be BI2L. You combine the two, you will get this formula. Now both the forces are equal. So you will get F is equal to F1 is equal to F2 and then this final formula. Okay? Yes. Next important question. Okay, you are also asked to define 1 ampere. What is 1 ampere? 1 ampere is defined as that constant current which is maintained between two long straight parallel conductors. This is actually from this derivation. Everything is there in the PDF. If you just read it once, you will understand all this. Next question. What is... Oh God. Okay. What is the principle behind working of a moving coil galvanometer? With the help of a neat label diagram, obtain the expression for angular deflection produced in a moving coil galvanometer. Okay. So what is a galvanometer? It is used to detect small currents. It's not like an ammeter, it can detect small currents. And the principle is electromagnetic induction. How is it constructed? Something like this. There is a coil, there is a magnetic field, okay? A soft iron core is placed between the poles, okay? And there is a spring as well. Alright? Yes. Students, you will not be able to study along with me these derivations. So that's why I'm moving very fast. So I can just quickly tell you what all are there. You can take the PDF and sit and study. Okay. So the class has been finished early enough because I want you to sit and study for the night. Alright. I'm concerned about your exam. If I take a late night class, then you will not have time to study. So that's why I've kept the class early. Okay. Yes. So torque is NIAB. So torque is K alpha is NIAB. Simple substitution you will get. Phi is NAB, K by I. Okay. Next important topic is refraction at a spherical surface. So for refraction at a spherical surface, the main formula is N2 by V minus N1 by U is equal to N2 minus N1 by R. Okay. If you know this formula, then you can derive the very famous, most important lens maker's formula. Okay. So for lens maker's formula, you need to know what to do. For lens maker's formula, one thing you need to know is the lens has two surfaces. So initially, imagine there's only one surface. Okay. So with only one surface, you will find out the image distance, object distance, focus, all that. And then what you will do, you will ignore the first surface, consider only the second surface. And then you will do the same thing, find out U, V and all that. Okay. Another important thing you need to remember for lens maker's formula is, from the first surface, there is a light ray coming and then there is an image formed. This image is going to be the object for the second surface. Do you understand that? The image of the first surface is going to be the object of the second surface. So look at this here. First surface, you have object distance is U, image distance is V. So this V is going to be object for second surface. And then you just substitute it, you will get the answer. Okay? Yes. Next, derive an expression for combination of two thin lenses in contact. So if you have two thin lenses in contact, what will you do? You will take first through lens A, then through lens B, and then add it. You will get the equivalent lens formula. Very easy. Yes. Okay. Yes. Next, very famous derivation is the expression for refractive index of the material of a prism in terms of angle of minimum deviation and angle of prism. So I'll tell you the angles here. So this is the incident ray. Okay. Now if the prism was absent, it would have gone like this. Isn't it? It would have gone like this. So this is the deviation because of the prism. First deviation. This is the second deviation. I2 and then R1 and R2. Okay. And then it's just substitution. The angle of minimum deviation, D is equal to dm at the dip, the lowest point. Okay. I put all the steps neatly so that you can understand. Okay. Next important question. Two coherent waves at a constant phase undergo interference. Obtain the expression for the resultant displacement. So y1 is a sin omega t, y2 is a2 sin omega t plus phi. And then what you do, you add them. You add y1 plus y2 and then what you do is you will get y is this and then you find out the amplitude and resultant. Okay. Yes. Okay. So that is also one more thing that you need to remember. Amplitude I is always proportional to a square. Okay. Next, write the condition for constructive and destructive interference in terms of phase difference. So you don't have to know the derivation. 1 second, students. Continuously talking for 2 hours. And my throat is too dry. I'm just doing it very fast because I don't want to waste your time, because you have to go study after this, right? Very concerned about that. Yeah. So you don't have to derive derivations for this. You only need to do the condition for constructive and for destructive. Okay? Yes. Next is, what is photoelectric effect and the experimental observations of photoelectric effect. So photoelectric effect is the phenomenon in which electrons are emitted from the surface of the metal. Okay? And then all the experimental observations very clearly in simple language I've put here. Okay? I want you all to read this. Okay? Very clearly I've put it here. Now the question can come in one another way also. It can ask, write Einstein's photoelectric equation. Using this, explain the experimental observations of photoelectric effect. So you can say E is equal to H nu. Okay? So the Einstein's photoelectric effect equation will be H nu is equal to nu plus kinetic energy maximum. So K max will be H nu by nu. Okay? So kinetic energy max is H nu by nu naught. Next is the explanation of experimental observations using Einstein's equations. Again, I have put detailed explanation. Next question, a very important question, a very famous question is, what is rectifier? Explain the working of a PN junction diode as a full wave rectifier and input-output waveforms. Okay, so the waveforms are also important. I want all of you to study the graph, the diagram, and how it works. So you have to talk about how it's going to be forward biased and reverse biased. Okay, and then half wave rectifier as well, waveform and working. Okay, so these are all very frequently asked 5-mark questions. So if you look at the past papers, 1 or 2 of these questions will definitely be there in every paper. Okay, these are all very frequently asked 5-markers. So if you study all of this, you will definitely be able to attempt at least some of the 5-markers. Okay, so I have already Okay, I have already discussed these derivations in my past package. That's why I've just skimmed through here. There I've not discussed, I've not talked about everything, but I've discussed most of the derivations in my past package. Okay, so I hope this has helped you. All those who are asking for numericals right now, numericals have done in the beginning of the video. Please watch the recorded version. Okay, so I've done all the important 5-markers and some of the important numericals as well. MCQs, I've done a video which is separate. You can go refer that for MCQs. For past package also there are videos. Okay, I hope all this will get your exam sorted. Okay, yes, done, super. So I'm winding up the class quickly because I want you all to go. Now no more distractions. Go take your pen, paper, sit, write and study all the derivations, solve the problems. Okay, all the best for your exam. Don't worry, rock it. I am sure all of you will rock it. Okay, so if you found this helpful, please let me know in the comments. Okay, I will be very happy to see that. Also, please subscribe and like our channel. Okay, because your support is what keeps us going. Okay.